just go ahead, throw it in there. Just go ahead and throw your questions into the Q&A, and we will definitely, I'll do my best to answer your questions. Well, thank you so much for having me. And we are going to take a bit of a tour through the solar system. Now, there's no way I could possibly talk about literally everything. We would be here for days and days and days. There's so much. But I want to show you a few highlights of our solar system. And so we're going to look at some planets. We're going to look at a few moons. We're going to look at some comets. We're going to look at some asteroids. And it's just amazing how much imagery we have from spacecraft that have gone to various places in our solar system. But the first thing I'm going to show you is just how many spacecraft are out there. It's something it's a graphic that I came across today. I've seen different versions of the graphic that I'm going to show you, but it really hits home to see how much exploration of the solar system there is. So let me share my screen. Give me just a second. All right. Okay. So, my title slide that you see here is sort of one of those generic images of the solar system. When you think solar system, you might think something like this. No, I did not purposely remove Pluto from the graphic. It's just that this was the only version of this graphic that didn't have the planets all pixelated and blurry and everything. So Pluto is definitely still there. Yes, I still personally consider it a planet. But this particular graphic, I chose it mainly because I just wanted to point out that graphics of the solar system, something that shows you a group of stuff, it's never going to show you size and distance to scale. And it's never going to be able to show you absolutely everything in the solar system. There are eight, nine, some number of planets in our solar system, one star, and that's where we get the name of our solar system. The name of our sun is Sol. And so the word solar system comes from Sol, the name of our sun. And so our solar system is our sun, Sol, and everything that goes around Sol and everything that goes around all that stuff. So we've got the planets, we've got moons. Moons are also called satellites, and they orbit the planets. Then we have asteroids and comets. And asteroids and comets are essentially leftovers from the formation of our solar system, stuff that just wasn't incorporated into other stuff. And so I'm going to show you some pictures from several of the many spacecraft that have shown us some great images in our solar system. And this graphic, and don't worry if you can't read it, that's actually, reading it is not actually the point. I just wanted to show you the array of stuff that's in our solar system. So where you see the sun at the top and all the names that are around the sun, those are the spacecraft that are studying the sun, either spacecraft or um, uh, instruments that are on other countries' spacecraft. So these are all US spacecraft or US instruments that are on other spacecraft. Where you see the Earth. So the sun is kind of near the middle, up near the top. The Earth, of course, lower left. Everything in green are Earth studying spacecraft. Pretty amazing. There are everything in orange orbits our Earth and studies biological stuff, so plants on the earth and various other things, and physical science related stuff. Where you see Mars at the bottom, those are the spacecraft that are studying Mars specifically. Where you see it says Escapade, that is a spacecraft that will get to Mars, I think, in about a year or so. It's not on its way to Mars just yet. It will be later, but so that one will be a Mars studying spacecraft. Where you see Jupiter, those are the Jupiter studying spacecraft or Jupiter bound spacecraft. Then you've got the Voyagers up in the upper right. They are at the edge of our solar system. New Horizons is out past Pluto. And then everything over on the upper left is they're basically the telescopes that study the rest of the universe. So just to give you a little plug for my talk coming up in February, I'm going to show you a bunch of images from spacecraft, just like the ones that are listed in the upper left part of this graphic. But today we're basically going to stick to stuff that's somewhere in the not upper left part of this graphic. So let's start with a scale model. And just to give us a sense of how big stuff is in the solar system, and the answer is the sun is the biggest thing, and everything else is teeny compared to that. So we've got the scale model of our sun, and then the planets there, those little tiny balls that are to the lower right. So the sun is more than 99% of the mass of our solar system. It's the largest thing in our solar system by size. It's the largest thing in our solar system by mass, the amount of stuff that's in one particular object. In this case, the most mass is in our sun. Now, our sun goes through cycles of activity. And if you've been paying any attention to the news in the last, about year and a half or so, our sun has been quite active, giving off flares and material, and we call that a coronal mass ejection. So flares, energies released, extra energies released from the sun, coronal mass ejection, extra mass, extra material is released from the sun. And if that stuff heads in our direction and interacts with Earth's magnetic field, hey, we might be able to see the northern lights or the aurora. But the areas of our sun where you tend to get that extra activity happening, you can see in this image right here. And those are those dark areas called sunspots. Now, that name sunspot tells you nothing about what a sunspot is. It just tells you about what a sunspot looks like. It looks like a spot on the sun. So, but those areas of the sun are a little bit more magnetically active than the rest of the sun. And so those areas of the sun are a little bit cooler. And so therefore they show up in our pictures a little bit darker than the rest. Now, just to give us a sense of how big these sunspots are, I'm going to pick out, maybe this sunspot right here. I think you can see my arrow. So it's that tiny one up above the large group near the middle. Now, this sunspot group, the big sunspot group right here, this is the group that created the activity level that then a few days later created the northern lights that we saw in May of 2024. And so, but this sunspot right here seems quite unremarkable, and it kind of is, but I just wanted to give you a sense of how big that sunspot is. Now, this is not that sunspot, but it's a sunspot that's about the same size. The average sunspot is about the size of the Earth. And so the one that I just showed you, the one that I circled right here, that's about the size of our planet. So it shows you the rest of these, many of them are bigger than our entire planet. And so here is the United States to scale with this particular sunspot. So they're big, and that's because you don't really notice it. It's because the sun is really big. If you could hollow out the sun and fill it with earth marbles, you could fill it with about 1 million earth marbles. So our sun is really, really big. Now, I mentioned a solar flare. This is what one of those looks like. This is a flare that occurred in August of 2020. Again, it's a relatively short burst of energy. So flares tend to last a few seconds to a few minutes, maybe a few hours. And then if they last for long enough, sometimes material is also released into space. And we call that, like I said, a coronal mass ejection. And where you see those bubbles of material coming out, that is a coronal, or actually in this case, several coronal mass ejections. And again, this was the set of coronal mass ejections that eventually resulted in auroras that were seen on Earth in May of 2024. And these are a couple pictures that were taken by a couple colleagues of mine at work. And they were just standing outside, and they are not astrophotographers. They are not aurora photographers. they took these pictures with their cell phones, and it's really remarkable how strong that auroral activity was. So if we get enough solar activity, eventually that activity may result in aurora activity that could be seen as far south as where we are. And in this particular case, even farther south than that. So there's been a few other instances of auroras that have happened since this particular display right here. So you never know. Keep an eye out, keep an ear out for maybe we get more aurora activity over the next year or year and a half or so as our sun remains at a higher level of activity. All right, now we're going to go toward the planets. And so if you just look at this scale model of the planets, one thing that is is pretty apparent is you can kind of start to group some of these planets together by size. You've got the two biggest ones. So we've got Jupiter and Saturn. So Jupiter is the largest planet, Saturn is the second largest. We call them the gas giants. It's a misleading term. They're not big, giant gas balloons. They're mostly liquid, and the center is some kind of slushy solid. The outside, what you see on the outside is the atmospheres, the gas that surrounds both of those planets. Then you've got the two next sizes. We've got Uranus and Neptune. One of the things I want to point out, please pay attention to the color of Neptune as it is portrayed in this particular scale model. We'll come back to that near the end when I talk about Neptune. So remember the color that you see here. Anyway, so we've got Neptune on the left, excuse me, Uranus on the left, Neptune on the right. Those are called the ice giants. And so they are not completely made of ice, but the interiors of those planets are made of a pretty slushy solid, pretty icy stuff. And then you've got the four smallest, those are the four closest to the sun. We call them the rocky planets or the terrestrial planets. And we get that word terrestrial from terra. That's another name for Earth. So that's the Latin name for Earth. And so we've got the two largest terrestrial planets are Earth and Venus. And then the two smaller ones are Mars and Mercury. So again, you just kind of take a look and you can sort of see some groupings. We've got the larger planets formed farther from the sun where it was colder. And we've got the rocky planets formed closer to the sun where it was warmer. But we're going to take a tour on outward from the sun out. So we're going to go in order from the sun and start with the planet Mercury. So here is a true color picture of Mercury. It looks a lot like our moon. So if you just glanced at this picture, you go, oh, it must be our moon. Now, Mercury is a lot like our moon, and it actually is a kind of that similar cratered look because there's no air, just like on our moon, no air here. And so it's been bombarded by stuff over the course of its history. And you can see those craters all over the surface of Mercury. You also see a lot of lines across the surface. Note this crater on the upper right. So something slammed into the surface of Mercury and stuff splashed out. And you can see lines of the stuff that splashed outward from that particular crater hit. And you can see others of these as well. Now, one of the most surprising things that we've discovered in our solar system, or at least what I'll will say is usually pretty surprising to most people, is while Mercury is the closest planet to the sun, parts of Mercury contain a material that you might be surprised to learn is there. So the side of Mercury that faces the sun, now Mercury does rotate, it just rotates really slowly, kind of like a really slow rotisserie. The side of Mercury that happens to be pointing toward the sun roasts at about 800 degrees Fahrenheit. The side of Mercury facing away from the sun, the side in shadow, is at about 200 degrees below zero. But at the poles of Mercury, you've got craters all over the place on Mercury, but at the poles, some of those craters are deep enough that the sun doesn't get high enough in the sky at the poles to have the sunlight fall on the floors of those of some of those craters. And so some of those craters are very deep and very cold. Over time, ice has collected in several of these craters. And so where it's colored yellow, artificially colored yellow in this picture, is where we have found evidence of water ice. So the same stuff that's in your freezer is in some deep shadowed craters on Mercury, the closest planet to the sun. It's pretty kind of amazing if you think about it. That what you would think as a scorching, roasting planet actually has areas of it that are quite cold. Now, where the ice comes from, still to be determined. There's a couple ideas of where it might come from. Some of it might come from comets. Comets contain ice, and some of the ice might collect in some of these craters over time as comets might hit the surface. There's a few other ways that you can get ice as well. But anyway, just wanted to surprise you right off the bat with some material that you probably weren't expecting on the closest planet to the sun. Now, Venus. Venus is um, the second planet from the sun. Venus is the hottest planet. It also is the most unremarkable looking planet on the outside. So if you look at it from the outside, you go, wow, that's boring. Venus is extremely bright in our sky here on Earth. If you've seen it in the morning before sunrise or in the evening after sunset, it's really bright. The clouds that you see covering the entire surface of Venus are very reflective. So that's why it appears very bright in our sky. And it's not terribly far away. So it is bright for that reason too. But what is the surface like? If the clouds totally cover the surface of this planet, what is the surface like? Well, until we started sending spacecraft there, we weren't sure what the surface of Venus was like. And there was a lot of speculation that was going on amongst the scientists of decades past. And I'm going to give you a little rundown of what some scientists thought the surface of Venus was like. So here's kind of, I'm going to paraphrase, but here's kind of the thought process. Okay, Venus, very bright. We look at it with our telescopes, can't see the surface. There's a lot of clouds. This planet is closer to the sun, must be warmer. If it's cloudy and warmer, it must be very humid. You know what must be on the surface of Venus? Jungles. Jungles must be on the surface of Venus. What lives in jungles on the surface of Venus? Dinosaurs. Dinosaurs live on the surface of Venus in the jungles that are below the clouds because it's warmer and probably really humid there. Well, you got to give them points for creativity. But I'm here to tell you that the surface of Venus isn't like that at all. Well, there were spacecraft that the Soviet Union sent to Venus in the 1970s and 1980s. I'm going to show you a couple of pictures from a couple of those spacecraft that actually landed on the surface of Venus to take some pictures. So I'll get to those in just a second. But those show us certain little bits of Venus. What does it look like under this blanket of clouds? Here's what it looks like. This is a radar image of the surface of Venus. And so it's the only way we can see the entire planet surface underneath the clouds. How you read a radar image is anything dark on the picture. So this area maybe to the upper left over here, anything dark on the image is flat. Anything bright on the image. So this brighter area near the middle is very rough and bumpy and jagged and rocky and all that. So that's how you read a radar image. So you can see there's a few areas that are kind of flat. There's areas that most of the rest of it is very rough and bumpy. The temperature on the surface of this planet is almost 900 degrees. Think about that. Mercury's hottest temperature is about 800 degrees. Venus, even though it's farther, is hotter. That's because the blanket of its atmosphere holds in the heat really, really well. And so think of the atmosphere of Venus kind of like a big giant snowsuit. And so that heat gets trapped and it doesn't go anywhere. So some people call that heat trapping capability of Venus's atmosphere a runaway greenhouse effect, because Venus's atmosphere is mostly carbon dioxide. And so it is very good at trapping heat from the sun. Now, what else do we know about the atmosphere? It's very dense, 90 times the air pressure of Earth's atmosphere. And these clouds that I showed you are mostly carbon dioxide and sulfuric acid. So, sulfuric acid clouds, 900, almost 900 degrees of temperature, and about 90 times the air pressure of Earth. This is an awful place to go on vacation. There's no dinosaurs here. This is not a good place to visit. In fact, those Soviet spacecraft that landed on the surface of Venus, this is one of them here. And as you can see, the picture, if you look at pictures of Volcano National Park in Hawaii, it looks a lot like this. There's a lot of volcanic rock all over the surface. And whoops, and here's uh, this rock, all this jumbled rock in the background. And here you can kind of see off into the distance. You can see the sky is kind of bright. You can't see the sun from the surface, but it's kind of like the equivalent of a bright sunny but cloudy day here on Earth. Um, but the reason it's kind of remarkable that there are these pictures at all is these spacecraft didn't last more than 2 hours on the surface. The atmosphere crushed them, the heat fried them, and the sulfuric acid ate them away. And so this is um, uh, probably this spacecraft is just a little puddle of liquid metal on the surface of Venus right now. So it is definitely a place that is not a great place for spacecraft. And actually, if we ever decide the humanity wants to send some more spacecraft here, they're still going to have a problem lasting more than a few hours on the surface because of those terrible conditions. If it's hard enough to keep computers cool on our planet, it's practically impossible to keep computers cool on a 900-degree planet. So, anyway, I'm not going to spend a lot of time on Earth and our moon because we live here on Earth, you know it. But I did want to point out just a couple of things about our moon. First off, notice the contrast between the barren rocky moon in the foreground and our blue marble Earth in the background. Our Earth is covered in liquid water, covered in atmosphere, covered in clouds. But it is a big difference between the surface of our moon and the surface of Earth, with one exception. Everything that is colored blue in this picture is where we found evidence so far that water ice exists on the surface of our moon. The picture on the left is showing you the area right around the South Pole of our moon. The picture on the right is showing you the area right around the North Pole of our moon. And so we have found, just like we have found evidence of water ice at the poles in shadowed craters on Mercury, same thing for our moon. And the reason that this is kind of remarkable is this, especially the South Pole area of our moon, is going to be a focus of future exploration, hopefully with people, with the Artemis program. And so sometime in the next few months, hopefully, we should be seeing the launch of Artemis 2, which is the first um, spacecraft mission with a crew on it on the Orion spacecraft that will be launched toward the moon, not to land, but to go around and back. It's a test flight of the Orion spacecraft, again, with a crew. So that is slated to launch sometime in the next February, March, or April. It could launch as soon as February 6th, although a lot of things have to happen before they figure out if it actually will launch on that date. So I'm not quite sure if it actually will launch on that date. However, the south pole of the moon especially is going to be a major focus of exploration precisely because one of the reasons is there is this water ice, or at least strong evidence that water ice exists in these shadowed craters on the moon. All right, Mars. The story of Mars is not just ice, but water. Mars is currently a frozen desert. Again, some of the ice that you'll find on the surface of Mars, especially at the polar caps, is water ice. There's also a bunch of water ice under the surface. And but the story of Mars in the past is different from how you see Mars today. Mars had active volcanoes. Mars had liquid water. At least we strongly suspect liquid water existed on the surface of Mars. There is a lot of evidence that liquid water existed on the surface. And if you take a look at this picture right here, you don't have to be a geologist to take a look at this picture and go, wow, that looks like a dried up riverbed. Because that's what it looks like to me too. There is enough water ice on and under the surface to, if you melt it, it would cover the entire surface. To what depth, we're not exactly sure. We're not sure exactly how much water ice is there, but the ice in the past, in the far distant past on Mars, the water ice that you see today at some point was liquid on the surface. Now, if you take a look today and you scoop under the surface of Mars, you'll find water ice, even just a few inches below the surface. And this set of two pictures was taken by the Mars Phoenix spacecraft back in 2008. And the white stuff that you see in this picture, that is water ice. And just it's under huge areas of under the surface of Mars. But I'm mentioning the Mars that you see today is not what Mars was like in the past. And so a lot of focus of exploration has been trying to piece together what the history of Mars was like in the past. And so the spacecraft that have landed on the surface, rovers and landers, have tried to piece all that together. Different areas of Mars, what have we learned from these particular areas? Well, the Spirit rover that you can see a little bit of it right here, um, churned up some of the dust where it landed, and they studied this lighter colored material where it churned up some dust. What did they find? That material that's in the churned up dust, that lighter colored stuff, is called silica or silicon dioxide. It's in such a high concentration in this particular spot right here that the only way that we know of to concentrate silica in that to that degree, at least on Earth, is liquid water had to play a part in that. And so the speculation is that this particular spot on Mars contained a hot spring, hot minerally water bubbling up from the surface. This part of Mars taken by the Opportunity rover. So you see the darker rock around and some lighter colored material in that line in the middle. So what we think this is from hot minerally water flowing through cracks in the rock. The water dried and it left the mineral behind. What this material is called calcium sulfate or gypsum. And another version of this material is plaster of Paris. I know you've heard of both of those. So you probably have some gypsum all around you right now. Or actually you might have plaster. If you have plaster walls in your house, this is the same kind of stuff. If you have drywall walls in your house, the powdery stuff under the paper and the drywall, that's gypsum. And so that's this stuff. How do you get gypsum on Earth? You need hot minerally water to do it. And how do you concentrate it? You flow it through rocks and let the water dry, and it leaves the mineral behind. Pretty cool. How about here? This is a picture on the left taken by the Curiosity rover in Gale Crater on Mars. So what you see on the left, rounded rocks stuck together. Picture on the right, rounded on Earth, rounded rocks stuck together. Where was the picture on the right taken? A dried up stream bed in Chile. Picture on the left is a dried up stream bed on Mars. And so this was a freshwater stream. We can tell by the minerals that kind of hold these rocks together. It was a freshwater stream. It's probably about knee deep. The water was not the hot minerally or briny water from the other two examples I showed you. This stuff was fresh water, and they think it was probably clean enough that you probably could walk out in the middle of this stream, wade into it, dip your glass down into it, and drink it. So this is really amazing evidence for fresh water flowing on the surface of Mars. Or this picture. Doesn't look like much. This is one of my favorite pictures out of all the Mars pictures and of most of the pictures taken of stuff in our solar system. This is one of my favorite pictures. Why? This is dried up mud on Mars. It's been sitting on the surface of Mars so long that it is now rock. But about 2-ish billion years ago, this was wet mud on Mars. And so you're seeing the last time that this particular piece of mud was wet. And then it dried and it sat on the surface of Mars for long enough that it turned to rock. So it's really kind of amazing that this exists, and we can all relate. You've seen mud, dried up mud looks a lot like that. Now, the mud in our area is dark in color because that's the color of soil that we have. But if you go down to the southeastern U.S. or the southwestern U.S., looks a lot like that, right? So it's pretty astonishing to think that you can relate to a 2+ billion-year-old rock on Mars. And then this is a portion of a crater. And so here are the crater walls, or a portion of the crater walls. This isn't the entire crater, but this whole part of the bottom of this picture. But the top third of this picture is the crater walls. The floor of the crater, a portion of it is here in the bottom 2/3 of this picture. This is a place called Jezero Crater on Mars, and this is where the Perseverance rover is studying right now. And why did they pick Jezero Crater? It's because of this. So if you take a look at this is a dried river on Mars, and this is a river delta. So the river carried dust and rock and debris into the crater. It flowed into the crater and deposited the dust and rock and stuff. And then what you don't see in this picture is there's an outflow part of the crater where the water came in, filled up the crater, and then flowed out the other side of the crater. And so why do we care about this? Well, the rocks in this area could preserve evidence of past life on Mars. Now, is the Perseverance rover going to find evidence of past life on Mars? Probably not. We would have to get those rock samples back on Earth in order to make sure or to check them out, because the instruments can't be miniaturized enough to stick them on a rover and send them to Mars. We need to get the rocks back in a lab on Earth. And so NASA's trying to figure out how to get some of these rock samples from the Perseverance rover back on Earth. So fingers crossed that that'll happen at some point. Okay, I'm going to take a quick drink of water. Give me just a second. All right, the asteroid belt. So asteroids exist in our solar system, not just in the asteroid belt. That's where you'll find a lot of them in between Mars and Jupiter, but there are others that orbit in various other orbits in our solar system. We've got some that come near Earth, and a lot of them are in between Mars and Jupiter. Many are much farther out than that. But one of the examples of an asteroid that does come near Earth from time to time is this one right here. It doesn't, I don't think it has a cutesy name, um, like Ceres or Pallas or Juno or Vesta or anything like that. Its name currently, I believe, is 2024 YR4. So what that name refers to is when the asteroid was discovered. And so um, it was discovered in 2024, and the rest of the name tells you which part of 2024 it was discovered in and what number in order it was discovered. So anyway, that's where that name comes from. But this is a set of pictures from the Webb Space Telescope of this particular asteroid. And so it was studying this asteroid in order to learn more about it because it is one of those that comes relatively near Earth every now and then. Um, then we've got others that are in the asteroid belt itself, and Ceres is the largest one. It's the only round asteroid, and it's round because it's big enough. It's about 600 miles across that gravity can pull it into a round shape. The rest of the asteroids are lumpy and potato shaped and bumpy because they're a lot smaller and gravity just can't pull them into a round shape. They have gravity a little bit, just not enough to pull them into a round shape. So while Ceres is 600 miles across, made of rock and ice, this one called Eros is about 20 miles in length and about 6 miles wide. So it could fit inside the borders of Chicago with some room left over. Or this one, Itokawa. It could fit between the Adler Planetarium and the Field Museum with maybe with a little bit of room left over. It's about 1,000 feet long. So uh, roughly in between the Adler and the Field. And so we have them in they're big ones from Ceres all the way on down to tiny ones. This one, asteroid Ryugu, is about 600 feet wide. So it could fit in between um, the Adler Planetarium and probably the Shedd Aquarium. And so this is an asteroid that a spacecraft visited not too long ago, a few years ago, and this is some of the material from that particular asteroid. So this is material that was returned to Earth aboard a Japanese spacecraft. And this is called asteroid Bennu. What's kind of amazing is there has been rock returned from this asteroid as well. This is that rock. If it looks an awful lot like the rock from Bennu, there's a really good reason. They think asteroids Ryugu and Bennu may have actually been part of the same original object, that something came by, slammed that object apart, and these are two of the larger pieces from possibly the same parent body. So kind of cool. That is actually new info as of, I think, just a few weeks ago. So we are learning stuff all the time. And then this is an artist's rendition of another asteroid called Psyche. This is an asteroid where there is a spacecraft by that same name, Psyche, headed here. This is an artist's rendition based on what we think the asteroid looks like. It'll be really interesting to see what it actually looks like. And Psyche, the spacecraft, will get to Psyche, the asteroid, in 2029. So 3 more years. So not too long to wait for that one. So, but we want to study this asteroid because it contains, we think, an awful lot of metal. The other asteroids contain an awful lot of rock and ice. This one appears to be very rich in metal, and so we need to learn more about it. It's a little bit of an oddball in the solar system. So more to come in about 3 years. All right, Jupiter, largest planet in our solar system. This is a true color image of Jupiter. So if you see those vibrantly colored images like this one right here from the Juno spacecraft, that's because these pictures like this have been color enhanced to bring out detail in the picture. So all the swirls and things that you see in this picture, it helps the human eye to bring out some of these patterns. So you'll bump up the contrast and the color in the pictures. It's not a faked out image, it's real. It's just that in order to bring out features in the clouds, they bump up the contrast and everything. So, but the atmosphere is very swirly, and a lot of storms and things are all those round shapes that you see in the clouds. The Webb telescope has studied Jupiter briefly, but one of the amazing things is you can see the rings of Jupiter. All the giant planets have rings. Saturn's is very apparent, but Jupiter's rings are very thin. And so a telescope like the Webb telescope can actually study them, where it's extremely difficult, possibly impossible, to study the rings of Jupiter from Earth because they're so thin and very dark. But something like the Webb telescope can see them quite well. And so um, Jupiter has quite a few moons, and this is one of the larger ones called Europa. And this moon is covered in ice, water ice. Yes, the same stuff that's in your freezer, the same stuff that we find on Mercury and the Earth and our moon and Mars and many of the asteroids. Many of the moons in our solar system contain water ice. And this ice may have an ocean underneath the ice. There's a spacecraft called Europa Clipper headed to Europa right now. It's going to get there in, I believe, in 2030, if I'm not mistaken. So more to come on uh, Jupiter's moon, Europa. There's another spacecraft headed to some more asteroids that are out there. Now, this is an artist's rendition of where the asteroids are in our solar system. So we've got some that are in between or interior to the orbit of Mars. And actually, this doesn't show them all. This shows some, but you can see they're also located in between Mars and Jupiter. Now, this is an artist's rendition. These are not to size scale. They would not show up in this picture if we showed them to size and distance scale. They are much larger in this picture, in this drawing, than they are in real life. On average, there's about 1 million miles in between each pair of asteroids. So you don't have to go bobbing and weaving through the solar system to avoid the asteroids. So this is just showing you where they are. But I wanted to point out there are some asteroids located in Jupiter's orbit. Some are ahead of Jupiter in its orbit, some are behind Jupiter in its orbit. And the group that's ahead of Jupiter in its orbit are called the Greeks. The ones that are behind Jupiter in its orbit, that orbit along with it, are called the Trojans. And so there is a spacecraft headed to one of some of these Trojan asteroids. It's called Lucy, and it's going to arrive next year to start studying some of these Trojan asteroids. So that is really exciting. I just realized just now that 2027 is right around the corner for the Lucy spacecraft to finally get there. All right, Saturn. Everybody knows Saturn. Everybody knows the rings of Saturn. And what are they made of? Stop me if you've heard this. Water ice. And so they're very bright, very reflective. Probably something very icy, like a comet or a very ice-rich moon, got too close to Saturn, and Saturn's gravity pulled it apart and formed the rings. The rings themselves may be quite young, possibly, in Saturn's history, meaning they may only be about 100 million years old, maybe, and they may only last about another 50 million years. We may be living in the time period in Saturn's history where it has rings. It may not have had rings all throughout it for most of its history. We just happen to be living in a time when Saturn looks like this. You can see one of its moons over here to the lower left and just to the lower right of Saturn as well. I believe that's one of its moons, also just above the rings there in the middle. Oh, there may be another one right over there, possibly. And if you look at the rings up close, they're really remarkable because of how big they are and how flat they are. On average, Saturn's rings are only about 30 feet thick. So find your nearest three-story building. That's the average thickness of Saturn's rings. And actually, some of them are pretty dense. This is a picture taken by a spacecraft. This is a real picture. Sunlight is coming through the rings and casting shadows of the rings on top of the clouds in Saturn's atmosphere. And so some of these rings are pretty dense, but some of them, like this right here, are not dense. And you can see um, that the shadows have different darkness depending on what the density of the rings is. This picture here is another one of my favorites. You can see some of the ring material right here. Some of the sunlight, or the sunlight is coming in from the top of this picture, and you can see the shadow of the rings, of the ring material that has popped up a little higher, and you can see the shadow on the rest of the rings beyond. Just shows you that they are more three-dimensional than you think. Saturn has 100 and something moons. I actually don't even know. It's hard to keep up. It has a lot. But this is the largest one of Saturn's moons. It's called Titan. And if you're thinking, wow, it looks a lot like Venus, there was a good reason because it's totally covered in an atmosphere, a hazy atmosphere. And it's the only moon in our solar system that has a substantial atmosphere. This is a picture, the same picture on both sides, just image contrast enhanced on the left. But this is a picture from the surface of Titan, taken by a spacecraft back in 2004. Um, and these are rounded icy rocks right here. Now this one that's kind of in the middle, it looks pretty big. I won't call it a boulder. It's not. It's only about 4 inches across. But you can see these rocks are rounded. The surface of Titan has various rivers and streams and lakes, not of water. It's much too cold for liquid water to exist here. These are rivers and streams and lakes of liquid ethane and liquid methane. And what you're seeing, if you take a look at some of the edges of this lake right here, you can see some of these rivers. This is another radar image. So remember, I taught you about a radar image. How do you read it? Dark, flat, light, bumpy. All right. So you can see the surface, the ground, and the flat lake, and possibly ripples, waves on the lake itself. The air on Titan moves across the lake, causes the lake to ripple. And so you can see that possibly near the edges of the shoreline of this particular lake. I'm not going to spend much time on Uranus and Neptune, and there's a really good reason. We don't know an awful lot about Uranus and Neptune. Both of them have only been visited once by Voyager 2. That's it. And anything else we've learned has been from spacecraft in Earth orbit, telescopes in Earth orbit, telescopes on the ground. So there's a limited amount of information that we have. But I want you to think back to what I told you to pay attention to at the very beginning. And that was the color of Neptune that you saw in that scale model of the planets. That's because everything that you might have thought about the color of Neptune might be wrong. So the Voyager 2 spacecraft went past Uranus and Neptune, took a lot of pictures. NASA released the pictures of both of those. Uranus was in 86, Neptune was in 89. And they released the images of Neptune, really pretty. They color enhanced the photo. And then everybody kind of forgot that they had color enhanced Neptune's picture to bring out features in Neptune's atmosphere, because otherwise it would be a little tough to see some of the features. People didn't realize that they actually did that. And so everybody since then I think if you've seen a picture of Neptune, it's been this kind of sapphire blue color. It's not actually sapphire blue. It's almost the same exact color as Uranus. So someone went back a couple of years ago at the University of Oxford. They went back to the original Voyager 2 data of Neptune and went, "Oh, it's it's almost the same color as Uranus." Now, why is it that light blue color? It's from methane in the atmosphere that absorbs the red colors and reflects blue. So there you go. That's where the color comes from. But if you've got a picture in your head of what Neptune looks like, and we're guilty of this at the Adler too. Our scale model image of, our scale model on the ceiling of our Other Worlds gallery has been up for a long time, and it's the wrong color also, but we can't take it down, so we got to live with it. But anyway, science moves on. Sometimes we learn new things and we have to change what we thought before. But Uranus is a really interesting place. It's basically a planet on its side. It may have gotten hit by something early on in its history that tipped the whole planet over. And then you can see the rings. This is a Webb telescope image. The rings show up very brightly. They're actually quite dim to visible light, but to the Webb telescope, they show up very brightly. And you can see the rings in this picture right here. Neptune has rings as well. And so this is Neptune and its rings, again, as seen by the Webb telescope. Um, so it's one way that we have to study these planets, even though we haven't sent a spacecraft there in literally decades. So uh, it's also very useful to use the Hubble Space Telescope to study these planets. We think that their interiors are very icy. So it'd be great to be able to learn more at some point in the future. Maybe we'll send another spacecraft there. Okay, last few slides and then I will get to your questions. So definitely throw your questions in the Q&A as you're thinking of them. So Pluto. Pluto is awesome. Pluto is one of my favorite places in the solar system. Pluto was almost nothing like, well, it was what we thought it would be a little bit, but a lot of it wasn't. And so especially this region right here, kind of near the middle of this picture, this is a very large icy glacier on Pluto. This glacier is made of nitrogen ice. This is a portion of that glacier right here on the right side of this picture. Now, all this craggy stuff over on the left, those are ice mountains made of water ice. Water ice is less dense than nitrogen ice, so therefore, water ice floats on top of nitrogen ice. And I call these ice mountains. These icy mountains on top of this nitrogen glacier are about the altitude, similar altitude in between like the altitude of the Appalachian Mountains and in between the altitude of the Rocky Mountains. So kind of in between the altitudes of those. So like 5 to 10,000 feet or so in altitude, big, tall, icy mountains. And so that nitrogen ice glacier had no idea that it would be there. Um, but one of the other remarkable things about Pluto is it's the largest object out past Neptune that we found, and there are a lot of other objects that seem to be somewhat similar to Pluto. So we call these trans-Neptunian objects. So trans-Neptunian means out past Neptune. And these are artist renditions of several of these named objects. And you've got Pluto and its 5 moons, Eris and its largest moon, Dysnomia. We've got Haumea, which really is kind of an egg shape. It is spinning so quickly that it has spun itself into an egg shape and it appears to have a ring and 2 moons. And you've got some of these objects are a little redder than others. Some of these objects are a little brighter than others, but these are all objects out past the orbit of Neptune, that this is a family of objects that all appears to be somewhat similar to Pluto. By the way, just to let everybody know, you may get to see one of my cats who has decided at this particular moment to show up for the talk. So I will just do this because I know everybody wants to see it. There she is right there. So of course she shows up right about when I am getting close to ending. But the last final slide I want to show you, and it never fails, right? Um, is comets. Comets are icy leftovers from the formation of our solar system, and they come from the farther, colder regions of our solar system. So you've got the sun in the middle, you've got the planets, you've got the rocky small ones closer to the sun, you've got the larger gassy and icy ones farther from the sun, you've got the leftovers in our solar system in between Mars and Jupiter, some of them. Some of them are out past the orbit of Neptune, and I'm trying to keep the cat from walking on my computer right this very second. So if you're wondering what I'm doing, that's what I'm doing. And so the icy comets are out farther, are generally out farther than the orbit of Neptune, and they come from a few different regions like the Kuiper Belt and the Oort cloud. And so we have an amazing array of stuff in our solar system. And with that, I'm going to stop sharing my screen. And she is in between one of my screens and my laptop. And so I don't know if we're going to get through this without the camera falling on the desk, but we will get through this as best I can. All right. So, how far were they from Saturn when they took that photo? I'm guessing you meant the one where where it was the rings and Saturn close up and the shadow of the rings on the planet. Not far, because that was taken by the Cassini spacecraft that was in orbit around Saturn at that time. So that was a spacecraft that orbited Saturn. And sorry, I need to get the cat down because she's about to climb onto something that she shouldn't. So I'm just going to hang on to her right here because that's what she wants. There we go. And so the um, spacecraft was there at Saturn when it took that particular picture. So I don't know exactly how far it was at that time, but it was in orbit. Is the US the country sending all the spaceships out? Are there other countries sending out spacecraft? And the answer is absolutely there are other countries that do that. So I'm probably going to forget some, but the United Arab Emirates has a spacecraft around, let's see, that is around Mars, I think, or is it the moon? Anyway, the United Arab Emirates has a spacecraft out in the solar system. I just can't remember where it is. India has a spacecraft around Mars operating right now. Japan has sent spacecraft out to various places in our solar system. Japan actually was the country that sent out a craft that got some of the material from the asteroid Bennu. Um, let's see, the European Space Agency has sent spacecraft out. We've got, let's see, European Space Agency, India, United Arab Emirates, Pakistan has sent a spacecraft to orbit the moon. Um, let's see. I'm probably forgetting some, but anyway, we're not the only country that sends spacecraft out there. So, what are the distance capabilities of the Hubble and Webb telescopes? It depends on what you're looking at. So, both of those telescopes can see objects in our own solar system and then out to some of the farthest reaches of our universe. It just depends on how long the light has been traveling. So everything, several of the, not everything, several of the pictures that I showed you were taken by those telescopes, but both of them can see objects in our own solar system, in our Milky Way galaxy, in other galaxies, and in the distant universe as well. So it's really difficult for me to say distance because the farther away something is, it's really how long has the light traveled to get here? And the object that has the light that has traveled the longest is a galaxy that the Webb telescope has imaged, and that object, the light has been traveling for about 13.4 billion years in total. Pretty amazing. So I just saw Neptune at the McDonald telescope and it was bright green. Why? So it was kind of that, it would have been that kind of a light teal color, but you're also seeing it through Earth's atmosphere. It may also have depended on how high Neptune was above the horizon, how much air you were looking through. So that may have affected the color that you saw. Also, human eyes work a little bit differently than cameras and instruments on spacecraft. And so human eyes see a slightly different amount of color depending on what color it is than our instruments and cameras do. So it may have been bright green to your eyes. The person next to you might have seen a slightly different version. Our eyes are all going to be a little bit different. So, but the key point is it was definitely not bright blue. You saw it as kind of a green or a light green. So our private companies sending out spacecraft. And yes, so you've got SpaceX that it send they're testing sending they will be testing sending spacecraft to the moon, possibly to Mars, maybe. Um, And Blue Origin is going to be doing some spacecraft testing to the moon as well. SpaceX and Blue Origin launch satellites into Earth orbit. So there are other countries and companies that do it. I totally forgot China. China sends up a bunch of stuff as well. So there we go. Let's see. I think I got them all. Did I get them all?
I think you did, yeah.
I think we did. All right.
Uh-huh.
Last call for questions while I take one more drink of water.
Okay, so going back to Mars, I actually do have a question. And
Yes,
please, you said that there was water on the surface of Mars at one time.
yep,
Now, Mars has it has a different gravitational field, correct? I mean,
correct.
um, what's the going theory? I know it changes all the time. What happened? Why is it off the surface? How did it get under? And
Yeah.
when it was on the surface, did it have a different gravitational oomph? I guess is the word.
Yeah, yeah. So the scientists would love to know exactly what happened to all the water.
Mhm.
So the gravitational pull of Mars is about one-third that of Earth. And it's
Okay.
it's always had that gravitational pull. So over time, Mars's lower gravity didn't allow it to hang on to air um, quite as easily. And so that air has been leaking off into space. So Mars's air probably was more dense in the past, which allowed liquid water, enough air pressure for there to be liquid water on the surface. And as the air escaped into space, the air pressure lowered, and then the liquid water wasn't able to stay on the surface. And at some point, obviously, some of it must have gone below ground. Now, exactly how that happened, we don't know. And how much of the water was lost to space, we don't know that either. Um, but the uh, one of the uh, one of the questions that scientists would love to answer is what exactly happened to all the water? How much was there?
Hmm.
Can we
Yeah.
figure that out? So anyway, big giant questions that we don't have all the answers to.
Hmm. Well, thank you.
No problem. So I'm
And
really I'm really glad that the cat has decided to, not jump around on the
she's
desk.
she's on your lap for a while.
She just wanted some attention. She's only been doing this a handful of times. When I'm giving a talk and all of a sudden she'll show up. I'm like, where have you been all day? I've been on meetings the whole day, and
On
now
cat
is when she
things.
shows up.
That's
So
right.
I know the audience probably wants to see her one more time.
One more time.
One more time. She's right there.
There she is. What's her name?
Her name is Dot. And
Oh,
that dot on her nose,
on her nose.
that's her Dot.
Nice.
So yes, her full name is Dotley Crew.
I love
And
it.
so
I love a good
anyway,
pun.
oh, I think we have one more question. The cat is adorable. I agree. And she knows it too. She knows she's
All cats.
adorable. Yes, they do. So anyway, thank you so much, everyone. I loved all your questions. Thank you. So from Dot and me, I hope you have a
That's
great rest of your evening. I will be back in February. And
right.
so we'll be
February
talking
23rd.
about stuff in our universe. So tonight was everything in the solar system, and we're going to talk about stuff outside our solar system. So things in our Milky Way galaxy and then in other galaxies out to the farthest reaches of our universe. So we are going to cover all that stuff.
We're
So
going to have a
thank you
good time.
so much for all the wonderful comments. Thank you to the two folks who just posted. I really appreciate it. Thanks a lot.
Thank you very much, and have a good night,
Thank
everybody.
you. Good night.
Take care. Bye bye.